Welcome to this presentation about inclusive design, where you'll learn how to design and implement inclusive applications that everyone in the world will be able to use. First, Matthew will be contextualizing the problem and tell you about the infrastructure in place, the hardware, software, and some tools and tips about how to get started. Then I'm going to be diving into the 7-step checklist, a checklist of things that you can do to make your application inclusive and legally so by the government of Ontario.
So our purpose here is to bring awareness to inclusive design, to give you all an introduction to implementing inclusive design in your applications and websites, and also to make it easier for developers to create inclusive applications. So just a quick accessibility overview. Me coming from an architectural background, the same way an architect designs their buildings to be accessible for all users, web content we create as developers must also be accessible for everyone. In essence, as developers, we are the architects of the internet. So not only is it unethical for you to design applications and websites that are not accessible for all users, but it can also be unlawful. If you're a company with over 50 employees, you can be fined if your document doesn't qualify. I'm going to go over first a few hardware-based assistive technologies. The first one on the list being alternative keyboards. So these can be keyboards that either just have a different keyboard layout than the standard, or have larger keys or smaller keys. These help with users who have difficulty pressing certain regular-sized keyboards. The next thing we have are electronic pointing devices. So in the picture here, you see Stephen Hawking. He's got an infrared laser mounted to his eyeglasses, and that's his form of input to his computer. Next, we have the sip and puff system, which you can see in the diagram of the girl with the straw connected to her mouth. And this works by either sipping and puffing through the straw or moving their lips around the straw. And that's how they interact with their computer there. Next, we have trackballs, trackpads, and touchscreens. These are things that every user commonly uses today in their smartphone, tablet, even desktop. And finally, we have braille displays. So these are for blind users. They can't see what's on the screen, obviously. So what will happen is the braille display will transcribe the information that's being displayed into braille text. They can feel what's being shown, and then they can respond accordingly. Next, I'm going to go through a few software-based assistive technologies. So these can exist either at the operating system level or the application level. The first one being light signal alerts. So this would be for a deaf user. If there's some kind of action or sound that's played to notify the user that something's happening, what will happen instead is the screen will flash to them to let them know that they need to do something. Next, we have on-screen keyboards. This is for somebody who has difficulty typing. They can only use a mouse or touchscreen or something like that. And we use this commonly in our phones today, mostly, but it's also available on most PCs, if not all of them. And with these come bundled with autocorrect word prediction as well. So these are things that make everyone's life kind of easier. Autocorrect even exists in word processing applications, and it really speeds up the flow of your work. Next, we have screen magnifiers. So this would be for a user who may not necessarily be blind, but does have difficulty seeing, and it will do exactly what it sounds like. It magnifies a portion of the screen, so just like a magnifying glass, to make it bigger and easier for them to see and operate. The next one we have are screen readers. We use these a lot in our application. And what this does is it will read certain code within your application or website, and it will transcribe either elements of a web page or certain commands into verbal text that the user can hear. So they wouldn't be able to see their screen, but it would be completely described to them so that they can still interact with it and create a picture of it in their mind. The next one we have is speech recognition. So this exists a lot today in the form of speech assistants or personal assistants like Siri. And what these do is they'll recognize your speech and either write out text, so you can create documents or even issue commands, launch an application. And conversely, we have speech synthesizers which do just the opposite. They will take your text and transcribe that into speech that can be spoken for someone who has difficulty speaking. So some users may require one or more of these technologies. Stephen Hawking is a great example of this. He has a computer that uses software which was developed by Intel. The software is called ACAT, which stands for Assistive Context Aware Toolkit. And what this does is it provides him an on-screen keyboard and a cursor, which scans the screen by row or column automatically. And like I mentioned earlier, he's got an infrared sensor mounted to his glasses. And what he does is he will move his cheek, and this will tell the cursor where it needs to stop on the screen for him to make a selection. And once he does make a selection, it will try to either predict his next action, so fill out the word that he's trying to type, and also predict the next word that it thinks he wants to write as well. So, like I mentioned, this software does provide word prediction, speech synthesis, and for him, it works for the infrared sensor, but it also works for other forms of alternative input. And although this software was initially developed just for his usage, it's been made open source, so now anybody who needs it can benefit from it. An important thing to remember here is that inclusive design benefits everyone. You're not just designing for a user who may require it, you're also designing to add convenience to every type of user because it makes everyone's lives easier. It really improves the user experience. And just like you see in the pictures here, there's a user who's in a wheelchair accessing a wheelchair ramp to get into the building. Or he may need an elevator to get up and down floors. Well, even though this is something that's really required for him, everybody uses a wheelchair ramp to walk up into a building just because it's easier, or just an elevator because it's easier to get up and down stairs instead. And a lot of these technologies are things that we use a lot, like I mentioned already: keyboard shortcuts, font size and page zoom, localization, and localization is just translation into your local language if you've never used that before. Voice recognition, speech assistance, autocorrect, word prediction, very commonly used by everybody, even though it's not really required for them. So the next thing I'm going to talk to you about are accessible colors. So as many as 8% of men and 0.5% of women are affected with some form of color blindness. That may not seem like a lot as a percentage, but it comes out to roughly 42 million people across North America alone, so that's a very large user base. And things you need to keep in mind with this are the text and background contrast ratios between your colors. And also that there's 3 main types of color blindness. These can be red-green color blindness, blue-yellow, or completely colorblind. And in the picture on the left, you can see the way a sighted user would see green and red. They can easily distinguish between the 2 colors. But a green-red colorblind user would see them as kind of like a greenish-brown. It's very hard for them to distinguish, so that you can tell that using these within your website or application might cause confusion for that type of user. And here's another example of that, where we've got a Rubik's Cube, and the way a normal user would see the cube, they can distinguish every single tile and be able to solve it really. But for another user who has some kind of color blindness, you can tell that a lot of the colors look the same, and it would be difficult for them to solve this cube at the end of the day. So how do you know which colors are good and what contrast ratios you have? Well, there's a lot of free tools online that you can use, and WCAG suggests a contrast ratio of 4.5 for small text and 3 for large text. And what's large text and what's small text? Anything that's 24 pixels or 18 pixels bolded is considered to be large. Anything smaller than that would be small. So this tool here, Color Safe, choose your starting color, and it will suggest an entire palette of other colors, and it will tell you the contrast ratio for each of them, and it will also tell you something better that it can suggest. And even though these are the baseline numbers, you should always strive for something better. So next I'm going to tell you how these assistive technologies kind of interact with each other. So first, an API in the operating system describes the role, state, and structure of the application's user interface. So in our example with the screen reader, software uses this API and also a text-to-speech engine to describe this user interface to the user. So then the assistive technology, whether it's a screen reader or another type, will access the DOM on a web page through the API to understand what each of the attributes are. And the browser will expose these ARIA-enabled elements to the API as native widgets. So what this does is it gives the user a consistent experience so that everything kind of translates the same way to the API, and it'll function the same way when they need to use it. So what's ARIA compatible with? Well, it's compatible with most major web languages such as HTML5, XML, JavaScript, even older versions of HTML. And it's also compatible with all major operating systems, browsers, and screen readers. So whether you're on Linux, Mac, or OS X, it won't matter. It's going to work in every browser, every operating system. Now, many front-end developers, they like to use UI frameworks, and you may wonder, well, does the framework I use support ARIA already, or will I have to code it in myself? The answer is a bit confusing here because most frameworks do implement some form of ARIA, but they don't go into detail about which attributes exactly or what standards they mean. So some really popular ones are Dojo, jQuery UI, Google's Material UI, WebEx. They do provide some partial documentation, but it's not enough to get you certified. So some better ARIA conformance UI frameworks that I can suggest are the Foundation Framework, Fluid and Fusion, which was developed at OCAD in Ontario, the Web Experience Toolkit, which is the UI framework that's used across all Government of Canada websites. It's completely free, open to use. You can see how their templates are used if you wanted to try those. And similarly, there's the US Web Design Standards, which they use for all their government and military websites. An important note about using UI frameworks in your application is that you always need to test your implementation. You can't assume that the framework has done all the work for you. Although the framework will do a good job of implementing these, you will still need to fine-tune each individual component so that you're giving a personalized message to each user so that it gives them a more natural experience instead of something that's really robotic. So what if you wanted to try a screen reader with ARIA? Well, ARIA is just written in HTML, and open source screen readers that you can use for each operating system include Orca for Linux, NVDA if you're on Windows, or VoiceOver, which is built into OS X. And if you want to test these implementations, you could also use Object Inspector, Accessibility Inspector, or ACC Probe. And W3C Validator actually does additionally validate ARIA code within your HTML5, so that's really handy. And if you didn't want to check it yourself, well, there's lots of auditing services available that they will review your code, test your implementation, and make corrections for you. So I'm going to pass this off to my colleague Laily, and she's going to talk to you.
So now we're going to get into the nitty-gritty and actually start programming. So show of hands, who has some experience with HTML? And who has no experience at all with HTML? Okay. So seems that there's more of an intermediate audience, so I'll go a little bit faster, but if anyone ever has any questions, feel free to put your hand up. So we're going to get A certified. First of all, let's talk about what does that even mean? Well, the Government of Ontario requires you to be A certified if you have a company more than 50 employees. And this is basically a checklist of things that you can do to make your application accessible for everyone. In the next 10 to 20 years, you're going to have to be AA, and then after that, in the future, you'll be AAA. So let's get into it. Step 1, create one page for all your users. Otherwise, this would segregate them from your other users. And this is really inhumane. In addition to this, just like Matthew mentioned, as we use an elevator, everyone benefits from these accessibility features, not just people who really need it, but it makes all of our lives efficient. Rule number 2. Use ARIA roles. This is an image of all the roles that you can use in ARIA. And if you look closely, you might even notice that you recognize some of them. For example, button or link or image. These are just things that you'd interact with on any web page. And that's exactly what roles are for. So roles tell your user what kind of component have they landed on. Is it a button? Is it a menu? Now, something very important is to not change the role once you dynamically set it. Let's say you have a user, they're using a screen reader, and they're listening to everything on their headset. And they've gone through the page once, and they've figured out sort of the layout of the page, where the sign out button is, where the menus are. And then once you change the role, if you do, then they're going to have to go and reorganize that whole structure. And it's going to take them longer to be able to use your application for what it's actually for. And also, the role is more important than the tag. We'll see an example of this, so you don't have to worry about it right now. So, we have a dog and a cat checkbox, and you want to ask your user, what kind of pet do you have? First of all, these are both checkboxes, so you want to give the role checkbox to both of these elements. Now let's hear what the visually impaired user would hear once they get to this part of the page.
Dog, unchecked, checkbox, cat, unchecked, checkbox, checked, cat, checkbox.
So it basically told you that there's a dog and a cat checkbox on the screen. And then once the user checks that checkbox, it said checked cat checkbox, basically letting the user know, hey, I just noticed that you clicked something there or you pressed a button there, and that interaction has been taken in by the system. So what's the code? Well, we can see the good practice and the bad practice. In the good practice, it's generally best to match your role to your tag. So the role is checkbox here, and the tag is input of type checkbox. But why this duplication, you might think? Well, tags already have some accessibility implementation already inside of them. So even if you don't put the role, it's going to be able to pick up some information. But because the role is more important, it's going to take precedence over the tag. If we look at the bad practice, we can see that it's a div, which is basically just saying this is a something that we don't know what it is, and we give it a role of checkbox, then the screen reader is like, oh, okay, now I know that it's a checkbox. So it's always best to use tags that are specifically made for what you're doing so that you can use those accessibility features that are already built into it. Rule number 3, use ARIA labeled by and ARIA described by. These are two properties, and you can put these on any tag. And this is basically your chance to really communicate with your user and customize that communication. Instead of it just saying button, you can actually get it to say whatever you want. And this way you make a very customized and relatable user experience. So ARIA labeled by gives a name to the element, and ARIA described by tells the user what can they do with that element. So let's look at an example. Me and Matthew work on developing Big Blue Button, an application at CDOT right here at Seneca. So this is the Big Blue Button page, and let's just focus on the settings button in the top right corner. So here's the code. This code here is what actually renders the button. And we see two attributes. Let's just focus on the two at the bottom there that say ARIA labeled by and ARIA described by. If you notice, their values, for example, menu ARIA label, match the values of the P tags, which are paragraph tags, at the top there. This is basically saying to the screen reader, once the user gets to this button, read out the text in those two paragraph tags. You might notice that there's an attribute hidden on those paragraph tags as well. This says don't actually show this to the user that's viewing the screen, only make it accessible to the assistive device. So in this case, when the user gets to this button, they'll hear settings button, change settings. Now they know what they can do with this element and what it is. Notice here that we're using the role to match the tag. And also, if you want to get a little bit more hardcore, you can see another attribute in here. ARIA has pop-up. What do you think that might be? It basically tells the user, if they click on this button, it's going to have a pop-up. It's going to open up a menu of different options they can choose. And you'll see what that looks like in a few minutes. Rule number 4, give all images an alt attribute. This is whether they're descriptive or they're informative. Why is that? Well, you want the user to have the same user experience no matter what. And so let's say you're using the color blue in your application to evoke a certain emotion in the user. You want the person who's visually impaired to have this exact same user experience. Now, when we look at this example here, we see that the sighted user sees a picture of a robotic wolf. So what is the visually impaired user here?
Welcome to VoiceOver. HTML content has keyboard focus. Robotic wolf image.
So the screen reader lets them know they're in an HTML area and they're viewing or at a robotic wolf image. This way, both users, all users, have the same experience. The code for this is surprisingly simple. We have an image tag. The source just tells us where does that image come from on the internet. And the alt tag, that's what the screen reader read out. So when it said robotic wolf image. So again, this is a chance to customize how you communicate with your user. Rule number 5, all interactable elements should be keyboard accessible. And that basically means if you can click on something, then you should be able to just use the keyboard to do that same thing. So looking at this example of a drop-down menu, you should be able to press Tab to get to categories, and then press the down key to open that submenu. Press the down key to get to development tools, right key to open up that submenu, and down all the way to item 34, and you can choose that item with an enter or a space. Now there's some defaults for this, like Tab, the arrow keys, enter, and space. And we'll talk a little bit more about how important it is to use these defaults. Another example would be if you press the left key, you should be able to move the slider left and right to go right. Now a big blue button example. You see now that the settings menu is open. It was that same button that we clicked earlier. And you see the options are full screen, settings, and leave session. So what is the visually impaired user when
Settings
when
menu button submenu. Full screen 1 of 4. Settings change the general settings to of 4. Leave session leave the meeting 4 of 4.
So it told the user that they're in a settings menu, and their options are full screen, settings, and leave session. But did anyone hear, there was actually a bug in this code. Did anyone catch it?
Did it say 404?
Yes, very good. And so it's actually looking at that line in between leave session and settings as another element. And the screen reader is mistakenly thinking this is a menu option for the user. So it's very important that you test your code and make sure that something that you're just using visually isn't being translated improperly for your user. Let's look at the code. Now looking at it like this may look a little bit overwhelming, but we can simplify it easily, like that. So it's basically saying, if the user presses space or enter, you want your program to do something. If they press up, down, tab, or escape, you want them to do something. And thankfully, in a lot of browsers, this is already implemented, these different keyboard accessible shortcuts. But in some browsers, not all of them will be. And it's your job as a developer to make sure that these work across all browsers. For example, Firefox usually does a lot better of a job than Chrome in implementing these. So test thoroughly, and you'll make sure that your user can access everything on your page. Rule number 6, ensure that there are no keyboard traps. So coming back to the menu here, let's say the user presses tab and gets to categories. And they press the down key, but this time the drop-down doesn't open. They try enter and space, the drop-down still doesn't open. So all they can do is just keep going to work, about, and loop back to home. And they're missing out on a lot of functionality on your web page. So it's very important to test for this and make sure your users aren't stuck. And this is the last rule. Notify your users of dynamic content. Remember in the beginning when we were talking about roles, we mentioned don't change the role dynamically. And this was because the user has an image in their mind of the layout of the page. And we don't want to disrupt this and lower their speed of using it. And also recall earlier, we were looking at some checkboxes, a cat and a dog checkbox. And as soon as the user checked that checkbox, the system let them know. So the first example is when you don't change the content. The second example, the user interacted with the screen, and in that case, you do have to let them know that something changed. Let's look at a third example. You want to send a tweet. So at the bottom right corner, just notice that it shows you how many characters you have remaining before you reach your limit. So what would the visually impaired user hear when they get here?
What's happening? Required edit text. Insertion at end of text. Characters remaining 112. You are currently on a text area inside of HTML content.
So the screen reader told the user they're in a text area where they can type something. They're also at the end of the text, and they have 112 characters remaining. Now if the user presses another character like I, then the number should go down to 111. And the user using a screen reader should also have the same experience. So how do you implement this using the programming code? Let's look at it. So you see the label at the top that says what's happening. That's simply just the title for the tweet. We have a text area, that's where you can type something in. And notice that it has ARIA described by input info. Do you see input info as an ID anywhere on the page? So you see it in the span right below. And the text for this span says characters remaining. So what does this mean? It basically just is saying to tell the screen reader to read the text here. ARIA required is true. This means that you can't just send an empty tweet, you gotta put something in before you press tweet. ARIA live is equal to assertive. Now, this means that interrupt yourself, interrupt the screen reader, regardless of what's being said, to let the user know that there are how many characters there are remaining. Now, the other options for this are polite, where it won't interrupt itself and it'll actually wait for maybe a second after it's done explaining everything else. And actually, users don't prefer this because they want to know as soon as something happens that it's happened. They don't want to wait to find out. But you might find in your case that your users may prefer something else. ARIA atomic is equal to false. This means present only the changed regions. So don't read the whole screen out from the beginning. If they press the cat checkbox, you just want to know that they pressed that checkbox. If the characters have changed, just present that. Don't read from the beginning of the page. And ARIA relevant is very similar. It's just saying only read out additions to the DOM. And those are your 7 steps to getting A certified. And now you can go out and easily make your applications accessible. And if you want more information, you can visit our blogs or visit some other useful web pages that we've listed here to get you started. Thank you for listening, and go get yourself A certified.
Any questions?
I have a question. Sure. On one of your slides, you showed a slider which had a numeric value associated with it. Do you have any advice about how to make sure that's accessible? For example, is there a way to communicate not only the current value, but also the range from maximum to minimum?
Yeah. So the example that Laily had here, where you give a span with an ID and you can give some kind of description, you would give that description to your slider. So you would tell them that the slider exists, has a range between 0 and 100, and then it would tell them also what position they're currently in.
There's ARIA attributes, minimum and maximum as well, just like there is in HTML. And also, once the text changes on the screen reader will read any visible text as well.
Oh, so according to, I guess, the priority that you give via assertive and all of that stuff, you could say initially when the page loads the minimum and maximum, or when you're interacting with that element, and then as you change it, it will only give you the updates in HTML?
Exactly.
Gotcha, thank you.
Any other questions?
I was kind of confused by that last example. When you're typing in a tweet, the number of characters remaining will decline.
Yes.
Does the screen reader tell you that your number of characters remaining every time you type in more text?
Yeah, exactly. With the assertive attribute, it's going to tell them.
So ARIA live, because assertive is to perceive the dynamic element.
Exactly, yes. Even if you don't have ARIA live, it's still going to tell you that it changed. But assertive just means to interrupt whatever they were already saying to say this, because it's so important the user knows it immediately.
Is there any way to pause it? Like if it were to interrupt at every character, it would become annoying.
Oh yes, that's what I was gonna address. You can have a setting where it reads out a whole word before it actually says how many characters are remaining, but the default implementation is right after every character. Okay. So it might seem annoying to us, but to people using screen readers, it's actually more efficient because they'll know what's going on at every step of the way. But if they're typing fast enough, the screen reader won't have enough time to keep saying it for every number, so there will actually be a delay. So it really depends on the user input too.
It also, it really helps the user because most cases if they're using a screen reader, they're blind, so they won't know what keys they're pressing exactly unless it's read back to them. So they want to know right away that they've spelled something correctly or missed the right key.
Any other questions?
How do you, like, if you've got an existing product, how do you incorporate this into your, not just your, like, the technology part of it, but how do you incorporate this into the design, into the actual design process of making the product? Like, what do you have to do to go from, we want to, like, we don't know about this, to we care about this, to we're shipping this? What does that look like?
So in our Big Blue Button project, we actually had some of the code that was already implemented without any accessible features added to it, and we had to add those in later. So it's always easier for the developer to develop with accessibility at the time that they're developing originally, but if you have to add it later, it's still possible, but it will be a more difficult process because you might have to change some elements to work with what you want to show the user. And like Laily mentioned, there's a lot of things that you need to hide to show just for the screen reader. So sometimes it'll just require adding ARIA attributes to things you already have, and sometimes you might need to change the structure of your page or application completely. And this comes because like we use, for example, lists or tables as a structuring thing sometimes, just for it's a visual convenience. But the screen reader will actually pick those up as tables or lists, and it'll read that to the user as a list or table, even though it may not be a list or table visually. So it can be very confusing for them. So those are the kind of things that you would have to change later.
It's very much a question of user interface design as opposed to the implementation. So if you can get the design right, then the implementation becomes a lot easier. But if you already have an application that doesn't have a good design, basically the structuring, then it's going to be a little bit more difficult. But as Matthew mentioned, it's definitely possible, and the only learning curve is reading some of the official documentation. I definitely recommend using other sources like blogs and things like that that regurgitate the information in a little bit more human way of understanding it. But as you saw in this tutorial here, the code is actually very simple. It's really just a matter of knowing what does each component do, how does it do it, and really getting into those details to understand it yourself before your user even does.
Are there coverage tools where you can look at this, like if you're in the process of that kind of migration, are there tools where you can look at, like just run the tool against your site and say, okay, this, you know, of these X visible features, 5% of them are missing the right hooks for accessibility, here they are?
I haven't seen any tools that will detect if your website is accessible or not. It really requires a lot of human testing. So I don't know about any automation tools like that, but there's a lot of services that they will do that for you.
We have some validators and testers listed in our presentation. I'll bring the slide up for you.
There is the HTML5 validator through W3C, but that just validates to check your code if you've implemented it correctly, not whether it works or not, or if it's the right application for it. But the auditing service there, if we make this slide available for you guys later, you can click it and it'll take you to an Ontario auditing website, and it'll give you a full, like it's a paid service obviously, but they will do a full audit of your application.
Okay, thank you.
I'm going to thank our speakers.